Alright, so we are going to have a look at a different example here. I have a different triangle. You'll notice the angle's a little different. And I just finished showing you the tangent ratio, which if you recall here, is the tangent of some angle theta, and in this case it's 13 point whatever we just finished seeing, is equal to the opposite side divided by the adjacent side. But even without knowing what the sides are, I know what the ratio is going to be by using my calculator. Uh, here's my angle there, 13.621. And with my calculator, I can tell you what the ratio is going to be right away. Okay, so there is my calculator. 13.621 is the angle. I hit the tan button, and the ratio is going to be 0.24. Okay, 0.242 or whatever. So without even knowing how long the sides are, I know that the ratio, the opposite side divided by the adjacent side, will be 0.242. So let me put the lengths in there and we'll actually compare it. Okay, so they're the side lengths, 2.399 and 9.9 for the adjacent side. The 2.399 is obviously the opposite side. Okay, and if we plug that into our calculator and we do 2.399 divided by 9.9, the opposite side divided by the adjacent side, we get 0.242, just like we already figured out from the tangent of 13.621 degrees. So that's always going to be true. Okay. Now you might be asking, well, what about the other angle? Let's take a look at the other angle here for us as well. 1 second here. And like magic, the other angle, there it appears before you, 76.379 degrees. So on your calculator, if you were to figure that out, okay, there it is there on the calculator, and hit my tan button, boom, it's 4.126, 4.127, okay? That means if you take the ratio, the opposite side divided by the adjacent side, you should get 4.127, okay? But note now that the opposite side to this angle, here's my angle, angle C here, the opposite side is this side here, the one that this eyeball kind of looks at across the way. This is the opposite side, 9.9. So on my calculator, I'm going to go opposite, so 9.9 divided by the adjacent side, which now is 2.399. This is the adjacent side now, okay? So now I'm talking about this other angle, divided by 2.399, and I should get 4.127. Look at that, just like before, okay? And so it doesn't matter which angle you talk about, the tangent ratio is the same for either. This also allows us then to solve for unknown sides. This is where the fun begins, people. Hold on to your hats. Check out this next example. Here we go. So here's a very famous type of problem for trigonometry. You're given a triangle with an angle and one side length, not the other one, and the instructions to find x. Okay, everybody, let's just make that joke right now. Oh, here it is. Woohoo, I found it. No, not quite like that. Okay, so to find x, we can use that tangent ratio because we know that the tangent ratio of 30 degrees, okay, is equal to, from using our calculator, okay, hit the tan button, and it's 0.5773. And I wouldn't even put it, I wouldn't even write it down like that. You're going to leave it in your calculator when you do this. I'm just writing it down for your benefit, okay? But we also know that the tangent ratio is, so the tan of 30 is equal to the opposite side over the adjacent side, okay? In other words, 7 over x, right? So here's tan 30 is just a number. It's 0.5773, whatever that number's in your calculator, okay? And then equals 7 over x. So what we're going to do then is we're going to solve for x, okay? With a little bit of rearranging, we multiply both sides by x, divide by tan 30, you get this. X is equal to 7 divided by tan 30. Do that on your calculator. We're going to go 7 divided by 30, 10, the way I use my calculator. And look at that. Hit the equals button, and boom, it's 12.12. Okay, so x equals 12.1, we'll just say. Okay, and that's what we do those. Okay, so last video then, next one, we're going to do a couple of examples, let you try this on your own, see how you do. Here we go.